All right, the second part of 11.1 is short. In this section, we're going to basically do the same thing. We're going to try to come to a conclusion about two population proportions, but we're going to do it using a confidence interval for the difference between the proportions. And this is basically a confidence interval just like we did in chapter 9. Just to review how intervals work, remember intervals have to be in numerical order. So the two numbers can both be negative, they can both be positive, or one can be negative and one can be positive, but if that's the case, the negative one has to be the lower limit of the interval. You can't have a positive number here and a negative number here because that's backwards as far as the number line goes. So when you calculate a confidence interval in this chapter, where these are the three possible outcomes, and you're going to be doing this on the difference between the parameters. So if both of the lower and the upper limit are negative, that means there's a significant difference between the values. In other words, it's not close enough to zero for zero to be in the confidence interval. And if they were basically the same, then the difference between them would be zero. If you have the lower and upper limit are both positive, that also means there is a significant difference between the values. Now this is a two-tailed, equivalent to a two-tailed test. This would not, we wouldn't use this particular method for a left or a right tail test, at least not in this application. If you have a confidence interval with a negative number as the lower limit and a positive number as the upper limit, that means that somewhere in that interval is zero. Because remember, this is an interval on a number line. It's all the numbers from this number to this number. If you go from a negative number to a positive number, you cross through zero. That means that zero is in here, and therefore, at whatever level of confidence you created this confidence interval, it's possible that zero is the difference between the two, and that would mean there was no difference between them. They were basically equal. And remember, that would support the null hypothesis if we were doing it as a hypothesis test. So if we get this kind of interval, it means there is not a significant difference between the values. And that's when the first number is negative and the second number is positive. If they're both negative or both positive, we'll conclude that there is a significant difference between the values, and that would be the equivalent of rejecting the null hypothesis. So we're going to use the 2-prop Z interval. This is one we haven't used before because we weren't working with two proportions before, and create this confidence interval to conduct this test. So let's look at this example first. We have a body mass index is one measure that is used to judge whether an individual is overweight or not. A BMI between 20 and 25 indicates that one is at a normal weight. In a survey of 750 men and 750 women, the Gallup organization found that 203 men and 270 women were of normal weight. Construct a 90% confidence interval estimate of the difference in the two proportions, and based on the result, does there appear to be a significant difference in the proportion of men and women who are normal weight? So for the men, we've got the 203 out of 750 were normal weight, and the women we have 270 out of 750, and the men are the number 1 and women are the number 2. So we're going to put that into this 2-prop Z interval, and this is way down the menu. So when we go to that menu, we've got stat, tests, and you have to scroll way down. There it is, the 2-prop Z interval. And so we choose that, and we have the values in there, the 203 for X1, and N1 is 750, 270 for X2, 750 is N2, and the confidence level is 0.9 for the 90% specified in the problem. So when we calculate this, we get negative 0.1286 as our lower limit, and our upper limit is negative 0.05. Those are both negative. That means that there is a significant difference between the proportions of men and women who are of normal weight. We're not saying what that is. We're just saying that there is a significant difference. The interval does not contain 0. These are both negative numbers. In the next example here, we've got among 5,000 items of randomly selected baggage handled by American Airlines, 22 were lost. Among 4,000 items of randomly selected baggage handled by Delta Airlines, 15 were lost. Use the sample data to construct a 95% confidence interval estimate of the difference between the two rates of lost luggage, and based on the result, does there appear to be a significant difference in the lost luggage rates? So we called American Airlines number 1 and Delta number 2, and we have the 22 out of the 5,000 for American, and Delta was 15 out of 4,000. Remember, these aren't matched up, so even though in some of the examples the samples were the same size, they don't have to be. These were different sizes. So we're going to go back to that test and put the numbers in for this one. So we're way down here at B. X1 is 22 out of 5,000. X2 is 15 out of 4,000. And this is a 95% confidence interval, so we're going to change this to 0.95. Calculate that interval. And it does give us the sample proportions. You don't necessarily need that for the test, but it does tell us what they are. And our confidence interval is 0.002 is our lower limit, and our upper limit is 0.00329. Now notice that in this interval we start with a negative number and we end with a positive number, so somewhere in between these two numbers is 0. It does contain 0, so that tells us there is not a significant difference in the rates of lost luggage, because at a 95% confidence it could be 0. And if the difference between the two proportions is 0, that means there really isn't a difference between them.